Okay, so this first afternoon session is on the transcognitive role of technology in language sciences, and who better to chair the session than Daan. Wiles, over to you.
Okay, so I would like to start by acknowledging the Ngunnawal people, the elders past and present, particularly to thank Shane Halloran for his welcome to country yesterday, and in particular for the Ngunnawal concept of Yinjamara. And this is often translated as the word respect. And in his talk last night, Clint Bracknell also emphasised the role of respect. There's a text session. What does it take to create culturally respectful technology? So this word Yinjamara, or the Wiradjuri cognate is one I'm familiar with, is actually on a poster in the lab where I work, Human-Centered Computing at UQ. Poster was put up by Susan Beatson, who's well-known Wiradjuri and UQ academic. And as has been explained to me, the concept Yinjamara goes way beyond the English translation of respect to encompass how we live, responsibilities, connections. In Midwestern New South Wales, there's this, in the Parks Library, there's this fabulous Wiradjuri exhibition. It's just opened. It explains Yinjamara as the respectful understanding of living well with and taking responsibility for country and community. There is a great need to bring such a deeply nuanced understanding of respect into designing and deploying technology. Good technology supports how we live, our identities and our connections. Good technology helps us fulfill our responsibilities and not distract us from them. So yesterday we heard about, and for the past 7 years, Australia's monolingual mindset. And technology embraces many banal languages now, but it still suffers from what we might call a monocultural mindset, particularly in the areas of automation and AI. And shifting this mindset is not easy. Brian Arthur is a complexity theorist who studies technology evolution. And he talks about the evolution of technology as needing 3 essential components. And I wonder if you can guess what they are. One of them is obvious. The other 2, less so. Okay, so I want you to think of an iceberg. The visible part of the iceberg, that's the tech you're developing. It's the app, the website, the online dictionary, could be a game, an archive, used to be CD-ROM. And this is usually what we focus on. Below the waterline, there are 2 hidden aspects. The first is what we might call the technology ecosystem. It's the infrastructure, it's our smart devices, internet speeds, programming environments, going from deep learning to WAV2VEC and open-face transformers, for those of you who are using those technologies. Game engines, so quizzes is one of the latest things that the Palmer Language Centre is investigating. Education on demand through YouTube videos. It's critical to understand the ecosystem where the device will be used and not just where the device was invented, developed. So that's one. The second aspect, which is often overlooked by tech developers, is the set of practices that bring the product alive. For language tech, how do they fit into the curriculum? Teachers' guides, worksheets, data management, the workshops that created the resource data, the language and art projects. We often don't realise or don't talk about these practices are as much a part of the success of a device as the device itself. So Brian Arthur contends that these 3 things, the engineered products, the technology ecosystems, and the human practices all co-evolve together, typically over decades. And a deeply nuanced understanding of respect needs to encompass all 3. For tech developers in the audience at this point, you're probably overwhelmed with the enormity of this. It's virtually impossible for any one person to swallow the entire iceberg. And I would say to you, take heart. In CoEDL, you don't have to do it all by yourself. One of the great things to learn is how to create diverse, culturally safe teams that can integrate both what's above and what's below the waterline. So in this showcase, we're going to hear about 4 language technology projects. I should say that CoEDL in these 3 days to me is a technology showcase as well as language and linguistics. But this one's going to be 4 projects, each one in their own ways navigating culturally diverse technology evolution. Our first speaker is Dr. Pete Worthy from the Florence Project. Pete, if you'd come up. The Florence team have been pioneering communication technology to support people living with dementia.
Thanks, Jen, and thanks everyone for the opportunity. It's probably good to clap before, just in case. So why Florence? Why are we looking at the issue of supporting people who are living with dementia and communication? And I think what's significant is the fact that for people living with dementia, communication changes. It's reduced over time and it continues over time. The impact on the person is significant and it's pervasive across many aspects of their life. It's one of the more significant losses that a person who's living with dementia experiences. And as the quote up here says, to just start being quiet. What does that mean for a person? Now, people are often asking us at the end of the project, where's Florence? And that's actually a really, really good question. Florence is not what we thought we would be developing when we started the project. And the image, or the cartoon on the right side, was kind of where we started, this idea that it would be a single device that would jump in and help a person when they were experiencing trouble with communication. But what we found out was that it can't be that. It can't be a single technology or a single device or a single thing. What we ended up creating, which is on the right side, is in fact that it needs to be many things that are connected, and they're often mundane things, things that recognise the fact that communication is embedded across all aspects of a person's life. In that respect, everyone's lived experience of their life is different, and therefore those things need to be specific to their experience of life, their life. The other thing is it needs to be something that responds to the fact that dementia is progressive, unfortunately. Plus those things need to be things that are actually going to help the person. So they need to be specific to that person's needs. So we ended up with an ecosystem of things, not just one thing. An ecosystem of things that are connected and sit within a person's everyday life. So how did we get there? And I don't expect you to understand all of this or try and read all of that, it's way too small. But we effectively had 4 streams of work happening in parallel. The first stream was about participatory activities. And that was about forming our team that included people who have the lived experience of living with dementia, as well as a range of other disciplines, and then continuing to engage with them throughout the life of the project. We had to look at what we called problem space activities, things that would help us understand people's experiences, understand the experience of dementia, and understand what happens as people try to use technology in ways that are going to be useful to them. And in that respect, we also had to understand context. What's actually going on when people are trying to use these technologies? Why, where, how, those sorts of things. And it's not just a person, it's a person within a network of people who are stakeholders. So whether that be someone who's, for example, a speech pathologist who's helping the person with their condition and the changes that are occurring, but it's also people such as those who care for the person who's living with dementia, because they also end up bearing some of the load of trying to use the technology. So we needed to engage with everyone. Then we had a series of design activities, which is the middle bar. And that was really a series of both inquiries and evaluations as we iteratively worked through a process of designing technology. And the one that I'm going to focus on today, because this is a technology session, is about the metrics and technology that we developed to help us with that process. So when we look at the technology, it's a series of things. we started looking at things that would help us create metrics and measures, and that was a system called CALPI, where we were looking at features of speech and what was going on so that we could try to identify when was trouble being experienced and how might we repair or help repair, or how technology might help repair. Then we actually had to look at, well, how do we make a system like that sustainable? How will other people be able to use these sorts of technologies? So we started engaging with a series of services that were already existing, whether they be cloud services or whatever. Then we had to look at technologies that were like machine learning and AI to help us with some of the processing that was there. And last of all, we started looking at this process of how do we implement what we sometimes call a language bank, but are probably now more calling a knowledge bank for the person. Across that, we had we had a lot of people who were working on this, but 4 people I wanted to highlight. So Daniel Angus, his background is in fact computer science person. And he was looking at different methods to help us work these sorts of things out from a computational perspective. Where is he now? He's actually working across a whole series of projects, given what's going on, looking at things like, for example, communication in media and what's actually happening in social media and newspaper reporting, as well as being involved in the Australian text analytics platform. Andrew's an engineer, and Andrew is working now in trusted autonomous systems, where he actually is looking at things like synthetic languages, and the Florence work helped with some of the work that he's doing. For myself, where I'm heading and where I'm working at the moment is using some of the knowledge that we gained and the technology that we developed, working with stroke survivors who are now experiencing and living with aphasia, and also looking at how we support people who are living with dementia but experiencing anxiety, use technology to help them with things like, for example, cognitive behavioural therapy. Jackie Little's an occupational therapist. Her experience with technology related to the Florence Project looks at things like quality of life. How do we look at and support people's participation within the general community and participation in society and general life, as well as looking at things like solutions to transport technology disruption, which we're all starting to experience at the moment. So the Florence Project looked at a number of technologies and developed a number of technologies that really have kind of branched off in many different directions. So to take you through the story, a little bit of the story, the first part, and probably the key part of our team, was the fact that we really wanted to engage with people who are really the experts in living with dementia. And so we formed a lived experience or a living experience reference group, and these people became part of our team. It was a dynamic team of about varying around 15 members, and they were either people who are actually living with dementia or had in some point cared for someone who was living with dementia. They told us right from the outset that our idea about the little box that was going to help people was a really bad idea. And what they told us was there were some really key messages that we really needed to understand. So things like, for a fact, everyone is different, and they're also changing over time. What they really need from technology is to make their day go better. They want technology to focus on their current strengths and skills, not on the deficits that we often focus on. And they also want to make sure that technology helps connect people, not isolate. Dennis is one of the people who's in our living experience reference group. He's a person who's living with dementia currently. Right at the outset, he actually came to us and said, I've got these ideas around technology. So working with Jackie, he created a list of things about what technology should do and what technology shouldn't do. And when you look through the list, it's more than just a question of usability, whether a person can use it. It's really things about making sure that technology is respectful, as Janet said, and we've heard about these sorts of things over the past few days, that it's respectful of a person's whole life and their whole series of needs that they have, not just completing a single task in their day. But those same considerations that we've spoken about in terms of language over the last few days also translate to the technology that we create to support people with things like communication. We have to understand that technology mediates our engagement with the world in many ways. Sometimes that mediation helps support things, sometimes it inhibits. And as Dennis said, we've got to make sure that technology does certain things and doesn't do things like, for example, reduce independence, focus on things like symptoms and deficits. And I think Dennis's message was a key one for us in terms of designing technology, that it's more than just the task or thing that a person is trying to do, it's what does it mean for that person in terms of their whole life and all of their needs. So with that, we got introduced to the disability dongle. And I do have to preface that with the idea that this is a pejorative term. It's not a good idea. The idea behind a disability dongle is that it's a technology that's been developed and it might work perfectly to solve a real or actually perceived problem. But it's been developed without people who have lived experience being involved in the process. Quite often, it's not practical. So we've got an example up here of the stair climbing wheelchair. But the stair climbing wheelchair is so heavy that no one can actually move it in and out of, for example, a car. Similarly, it puts person or people on a really precarious angle where they feel quite unsafe. So it seems like a great solution, but actually it's not. And in fact, what it does do, and what often disability dongles do, is they shift the onus onto the person with the disability rather than solving the issue that exists in the first place, safe environments for people who have disabilities. So we needed to make sure that we didn't end up in the land of disability dongles. And certainly that was a message that came very strongly from our lived experience reference group. So we started looking at, well, what's going on with technology in people's lives? And that's when we started uncovering all of these sorts of strategies that people put in place to help them with managing technology. And we call that the trouble with technology. And it does actually show us a few things. It doesn't just show us what people are doing to try and manage it. It also shows us that it focuses on people's strengths. The strategies they put in place enable people to continue to do things rather than shifting control away to something else. So this is not about actually shifting it away from the person. It's making it easier for them to continue to perform the things that they want to do as part of everyday life. And that became a very clear message for us as we started to develop technology. In terms of technology, we needed to actually engage with ways that we could understand things in the wild. So whilst we can analyse speech, often that takes a lot of time. And that's not going to help a person in the moment. So for example, if you've got a device that takes 3 minutes to jump in and say, I think the word you're looking for is this, that's not going to be very helpful at all. In fact, it can derail things. And as our lived experience reference group told us, it can derail things for the rest of the day, not for just that moment. So we started looking at ways that we could actually do this, and we developed a system called CalPi, which allows us to analyse speech in the ways that are going to be helpful to us. It covers things like prosody abstraction, but also something that was really useful for us, analysing pause and who owns what pause. And this is largely Dan Angus's work along with his team of people. We also worked with Andrew Back and tried a different approach to start to understand what might be going on in speech. And he took an approach that looked at entropy and fast ways of measuring entropy in speech. So again, another way of looking at, well, how can we identify when things are going wrong in a conversation? So all these things form the basis for us to then be able to move forward. In terms of the language bank itself, as I said, it's not a single device. What we have is an ecosystem of different devices that plug into a central processing system along with a graph database that allows us to continually to access or continue to access that information. So the idea, for example, is someone may have a photo sharing app where they can share photos with their family. People record a quick description of what's in the photo sharing app. Our system, at a very low level, translates speech to text. It also then extracts key bits of information from that system to help us understand what are they talking about. The triples that we put into our knowledge graph. The knowledge graph keeps that information but then allows retrieval to occur by other devices. For example, a calendar that's looking at a meeting in the future, maybe someone's going to the market, it can retrieve the most recent photograph related to that thing and put it into the calendar. So it means that it becomes something which is, I guess, embedded in those things that people use every day with a system sitting behind it. The key issue that we saw with this type of system was the task and load of trying to get all of the information that it needs into it in the first place. It's a lot of load for someone to sit down and have to put all of that information in. So embedding it into devices and things that people use every day means that it happens over time and gradually over time. It also means that it can change and respond to changes in the dementia and the issue that people are experiencing. That way it stays up to date. So the most recent picture of something is what's retrieved, not a static image where maybe I've changed my hairstyle, probably not, but it means it's difficult for a person to recognise if that happens. In terms of those things that sit within a person's life, we also had to explore, well, what is it that people need and how will people be able to use this? Because the problem in a lot of these technologies at the moment is there's really low uptake. In fact, there's a lot of non-use as opposed to anything else, even misuse. So we started looking at, well, what is it that people need? And it's more than just things that are usable, it's things that are understandable for people. And that's where we needed to understand, well, how do people make sense of the world and completing a particular task? So, for example, listening to music, streaming on a phone doesn't make sense to a lot of people, whereas playing with a cassette player does. So how do we put our technology into forms that people are actually going to understand and be able to use? Bring back buttons so that people know how to actually interact with things. We've developed a range of software, and we have a system where we've basically got all of the software on display. Everything from an onboarding system where a person can teach a language bank, because they told us that they wanted to be able to do that. Also to be able to see, how does it know what it knows about me? So that people have control and have understanding of the system. But all of this software can be embedded in different things, even though it's sitting on a website at the moment. So the music player is an example of that, and we designed that with people who are living with dementia. But the thing with the music player is that it can take many forms. So we've got two forms up here. One's similar to a very old style Bakelite radio with a single knob that people turn on and off. The other one's a bit bigger with really obvious buttons and a form that people can make sense of. So it's easy for them to interact with that. But it can also be remotely changed in terms of the music list that's there, and also it can be turned on by our system remotely as well, if that's going to be useful for a person. In terms of designing these things, as a side output, we learned how do we actually work with people living with dementia, dealing with issues of distance, COVID, but also the cognitive need of people who are living with dementia. We're still working on producing some of these things, and some of these things are still actually underway at the moment. So, for example, rather than using your phone to share photographs with people, a camera that does the same thing, something that people can make sense of. We created very early on in the project the ability to record these voice memos. So you could go back and look at what did I talk about during the day, but the data goes into our system. But putting it into a form that might look like, for example, a microphone with a clear push-to-talk function, something that might sit on someone's desk so people can make sense of what that's all about. And how does the information present back to people? The Rolodex that we used to have on our desks many years ago. I think there were other things that came out of the project that were probably more significant. So the first one, the importance of involving people and the nature of that involvement. I think it's a recognition that lived experience of something is expertise and should be built into a project along with any other expertise that you build in. There's no one silver bullet. There's no one device. We need to make sure it's something which is going to be useful for people, and that depends on their life and their experience. I think a key thing about Florence is that it is made by and for humans rather than anything else. We are going through a process at the moment that's a bit reflective. Learning what we've learned as a group of people who are multidisciplinary, which encompasses computer science, engineering, psychology, OT, speech pathology, and interaction design. We're going back over our data and we're starting to look at, well, what was it that we actually understood? What was it that we learned? And we're producing an output, I guess, which really is meant to be inspirational more than anything else. I don't know that it's generalizable, but it's certainly something that was important to us. And it's all the things that are important in terms of technology design, but also what's important for technology to be. What does it need to recognize and respond to in terms of a person's life? That's everything from the fact that the person at the centre isn't a single person, I've talked about that, but also for the need for technology to respond to things like participation. What does that mean? Physical well-being and things like safety. A person's sense of self, their identity, their autonomy, their competence. Connection and social identity related to connection. The understanding of a good day. So the emotion, the need to flow. For example, the fact that if technology goes right, then you don't even think of it. It's only when things go wrong, that concept of flow. Also the fact that for us, it needed to respond to change, but it also needed to support continuity. What's the way that people are used to doing things and completing tasks? How do we make sure that it doesn't disrupt that continuity that exists in a person's life? Thanks.
We do have time for one question. Someone wants to ask one?
Just over there.
Thanks, Pete. That was really great.
Thanks.
I'd love to hear more about, I think you said it can detect different kinds of pauses. That was a crucial part of it. Could you explain more about that?
Well, for us, what we wanted to know was who was owning a pause in a conversation. So what we tried to do is work out if there is a pause that's happening, who owns it. So for example, if a person living with dementia is struggling to find a word, we didn't want to detect that just as a standard pause, but it's just something that's occurring naturally in a conversation, as opposed to a pause that might occur as people switch between who's speaking, or a pause that might naturally occur just as we stop talking about something and switch to something else.
Okay. We probably should be moving on. Please keep the questions for the break. Mark.
I'd like to acknowledge the number of people on whose lands we meet today and the data people whose lands I work on in Sydney. I would also like to acknowledge all the people and groups on this slide who have and are contributing to the resource that I'll talk about today. In particular, I'd like to acknowledge three gentlemen elders, Esch Conway, Jesse Roberts and Amy Dirndike, whose recordings are at the heart of this resource. As Josie's aunt has only recently passed away, I refer to her by her first initial and surname at the request of Josie. I won't talk about all of the people in detail on this slide, although I'd love to. Just a couple. So Josie Lardy grew up at Gilbingham and has been a key collaborator since the beginning of this research. She brings a wealth of cultural and language and local knowledge to the project. And a number of people, some of them sitting in this room, have mentored her over the years, including Denise Angela, who's been working with Josie since her high school days, which is also when I first met Josie. Guana Moran is a dynamic Birpai woman who takes a leading role in her community through her work as an Aboriginal Languages and Cultural Advisor on early childhood education with the New South Wales Department of Education. And as part of, was a leader of the Jagu Community Governance Group. Gwanyang is also co-researcher with Caroline Jones and myself, investigating the development of a digital learning resource for the Gatang by one of my Gurinai communities. I'd also like to thank Caroline Jones for her amazing guidance throughout this research, and of course Francesca Merlin, whose amazing documentation of Manggarai since the 70s, and she still engages with that community today, has been is essential to this kind of project. And of course I'm indebted to CoEDL for providing funds for this research, but particularly personally for giving me the opportunity to explore this space. So this is just a bit of an overview of where we're starting, hopefully where we'll get to. This is Josie Lardy, hard at work at the Juppingen Language Centre, we like to call it. It used to be the government complex, which has now been given back to the community, but we've claimed it as the Language Centre. So Manggarai is a non-Parliamentary language, that is, it has lots of prefixes and suffixes. Today the largest concentration of Manggarai people can be found at Juppingen, an Aboriginal community in the Northern Territory on Manggarai land. Manggarai is no longer spoken in daily life at Juppingen, but there's a group of young adults who are keen to learn to say things in their language, particularly around everyday contexts. However, there are now few opportunities for learners to hear spoken Manggarai. Recordings made in the 1990s as part of a documentation of a project to develop communicative language teaching and learning resources for the Juppingen school offer one potential source of spoken Manggarai language. Research together with the community in 2016 suggested that chunking the recordings into shorter phrases could be helpful for learners. So while Manggarai, or listen to Manggarai, is one such resource, in 2020 Caroline Jones and I received CoEDL funding to co-design a digital learning resource based on this idea with the Juppingen community and app developer eLearn Australia. The collaboration employed user-centered community co-design principles so that the end users, that is, Juppingen community adult members, were part of the whole design process to ensure that the design was informed by local knowledge to maximise the chances of the resource meeting the learning needs of the community, much like exactly the same way that Pete has just been talking about in the previous talk. A group of Juppingen adults were part of the design team to develop a prototype that was then presented to the wider community for feedback. This was conceived of as a reference tool. Users could search for and listen to phrases of interest. Version 2 incorporated the community feedback and targeted learning activities were developed. This was then turned into an app, and community members were invited to try it out and give their feedback on the experience through a semi-structured interview. User data was also collected to provide insights about the way learners engaged with the resource. Okay, so that's right. 4 different screenshots here show the 4 layers of the app. So the home page with the main topics, subtopics associated with these, and Manggarai phrases, audio and written English translation on the third slide there. So these can be searched, and I'm going to use this function here, so you can search using the either a filter, so that's for, you can get Manggarai keywords, English keywords, language function keywords, so asking questions or all the phrases that might be about asking a question, etc. And even linguistic keywords we'll put in. The algorithm first searches, and sorry, there's also the text box up there, which works on an algorithm where the more you type, the more it narrows the search. So the algorithm first searches at the beginning of a phrase, Manggarai, then English, and then finds where the string occurs anywhere in a Manggarai or English phrase. The phrases are listed with the search term bold. So the idea, part of it was that if you perhaps knew a Manggarai word and you thought, remember the first few sounds, you might have a chance of finding it. So each letter you type will get closer to it. and then when you see it, it's presented in a context of a phrase. Then if learners click the ear symbol here, they can access features designed to support comprehension and understanding of phrases. So they can slow the phrase down to about 70% of full speed. They can access interlinear glossing that uses colour. We'll see that in the next slide. Here, actually there's the next slide, so this here. So it uses colour and transparent terminology. So unlike perhaps linguistic glossing that we're used to, which tries to capture as many nuances as possible, this tries to give learners an idea, a general idea of what that bit does and what it can be used to communicate. So it gives that information about grammar, morphology and structure. They can see an image and also other phrases. So here this kind of yarning up. In the database, phrases are tagged that in some way go together. It could be as a question answer, but in some way go together to give you a sense of perhaps a longer text. And also, crucially, because in that part of the world, many of the committee members speak Creole, a Creole-based, English-based language, not English as their first language, and so it was important to have the phrases not just in English but in Creole. So they were recorded by Josie and Bernice Swanee. So why language chunks? In the research at Jukmingen, an organisational framework called Chunk Bank was developed around topic, subtopic and language function as a means of providing rich contextual information about how learners could use a phrase to communicate. Because this was a key concern, people wanted to say something. The multi-word chunks model authentic grammar, structure and pronunciation for learners without the need for explicit knowledge of these, providing a repertoire of phrases that can be used to communicate in given contexts. So this can be particularly helpful in the early stages of learning. More recent neurological research shows that up to 70% of language may be stored as multi-word chunks, and repetition of these improves speed of neurological processing. At the same time, through repeated exposure to chunks, learners begin to notice patterns of grammar and morphology, and this encourages transfer. So learning a language by learning chunks only is not the most ideal way of doing it, so you should notice patterns that can help that process. And the coloured glossing aims to facilitate the process of noticing these patterns. Deliberateness, so although the first version of the app was conceived principally as a reference tool, like many reference resources, it can be used to learn. For example, pressing the play button over and over and listening back and repeating is a very sensible way of learning. You can also use the slow function and the favourites and the glossing. But targeted learning activities were developed in the second version, the V2, and they were underpinned by the notion of deliberate learning. It's been shown that deliberate focus on word learning is effective in expanding vocabulary, but learning vocabulary in context rather than lists makes it more available for communication. So Paul Nation identifies three main processes for deliberate learning. First, the learner has to pay attention to the word, or in this case, listen to and try to remember the phrase. And although conscious, subconscious noticing may also is going to play some role. And this process should be repeated. Retrieval involves actively recording a word or phrase, in the first instance recalling the meaning of the target phrase, and then a harder task recalling the target word or phrase from the meaning. And thirdly, the learner tries to say the word or phrase given a cue, a meaning cue. So the screenshots show here how we've tried to operationalise deliberate learning strategies in the learning activities. In level 1, the learner hears a Mangrai phrase with the transcription and has to select the best English translation from the three options. They can listen to each of these in Creole. They can also replay the Mangrai phrase and slow it down. And if they get it right, they receive positive feedback. Yo, ija. And if they get it, that's Josie, I'm channeling there. And if they get it wrong, they're invited to try again. Actually, Josie says, hey, no. And the activity, so the learner will succeed after a maximum of 3 tries. The activity selects 10 phrases at a time from the corpus, either from the learner's favourites or beginning with the shortest phrases, which are presented randomly. When the learner receives 3 points, i.e. successfully retrieves the phrase 3 times, they move to the next level for that phrase. At level 2, the learner is presented with an English meaning, spoken and written, with the option of hearing it in Creole, and asked to select from 3 written memorised phrases, which they can also choose to listen to. The point scoring is the same. Actually, the points, everyone's decided in the group that these are Inuits, so we get an Inuit. At level 3, the learner hears and sees an English phrase that they can choose to listen to in Creole and record themselves saying it in Mangrai. They listen back to their recording and compare it to the original. The learner has to make judgments about correctness of form and pronunciation, an important skill for language learners. When they're happy with the recording, they click your, yes, and receive a point. When they receive 3 points, they are deemed to have learned the phrase. I should have added too that if they don't think that it's right, they can have another go and another go until they feel happy with it, and then they get the point. So feedback, theoretically, after going through this process, you could say you've learnt the phrase. But learners reported back, of course, saying some of them, well, I don't think I have learned that phrase actually, and really wanted a button to allow them to go back down and start again. So I think this really shows that learners, at a certain level of engagement, but self-awareness of themselves as learners, which I think is crucial, and certainly is from a language teaching point of view. So learner engagement is at the heart of positive learning outcomes. John Hattie equates engagement with perseverance, and his work on visible thinking explores a vast array of factors that encourage students to invest in learning. The motivation for the research at Gilpingham was to provide adult learners with opportunities for exposure to authentic Mangrai. However, more than exposure, it's the extent to which learners actively engage with the language content that will promote learning. Agnieszka Svalberg identified learner behaviours across the cognitive, affective and social domains, characterising engagement with language. As she makes clear, of course, these domains are not siloed, but interrelated. Warama Mangrai was designed to offer learners opportunities for engagement with language, and as part of the app development, we wanted to gauge this. So during the user testing phase of the second version, V2, between May and July 2021, adult Gilpingham community members were invited to use the app for about 20 minutes a day for 5 days. 2 types of data were collected: user data extracted from the app for 17 users, including the features and functions users interacted with, individual and aggregated time users spent on the app, number and length of sessions, and number of phrases interacted with. Semi-structured interviews were conducted with 8 participants to get their views about their experience using the app. Engagement with language was used as a framework through which to consider what the data could tell us about how learners engaged with language. And it's really important to distinguish here between engaging with an activity, engaging with an app. So we know that kids can perhaps spend a lot of time using an app or a resource, but that doesn't necessarily equate to engagement with language, and engagement with language is what we're concerned with here. So this graph shows us the percentage of different interactions. So we can see that play, just when someone presses play, represents the largest proportion of interactions. Open, which is the next largest, so that's the one, the ear one, that takes you on to these other possibilities, such as slowing down, etc. Glossing, favourites. The learning activities together represent 13%, so that's up here. And unfortunately, so there are 3 learning activities, but you only see 2 represented, because unfortunately the data for 2 and levels 2 and 3 got conflated, and we weren't able to distinguish the 2. So overall, learners spent an average of nearly 80 minutes engaging with language in some way on the app. As we saw on the previous slide, the play function represents 55% of these interactions. This in conjunction with the fact that the median number of phrases interacted with was 39, or about 6.5% of the 603 phrases in the app. Learners engaged with each phrase about 1 to 5 times, but a number of users engaged with phrases up to 10 times or even more. So this suggests cognitive and effective engagement, focused attention, and positive, purposeful activity. Of course, it's kind of an inference, because really to know what someone's doing when they press a button, you would want to be there to observe what they're doing. We weren't there, but we can make some inferences perhaps about what was happening. So the learning activities, as we said, together represented 30% of interactions. And although we can't tease apart the data for activities 2 and 3, learners reported completing the 3rd level. Again, this suggests learners taking active control of learning to construct knowledge. Learners reported using the app collaboratively with family and friends, as well as on country, to find words, but valued having these given to them in context, which could be used for some form of communication. There was minimal interaction with the glossing feature. As we said, designed. It was specifically designed to try and help cognitive engagement. Perhaps because people really didn't know what it was and needed more explanation, and probably also because an analytical approach is not really the favoured approach to language learning at Wolfgang. So, although Mungerai is designed with one community for their context, it was thought that this tool is likely to be useful right from the beginning, that this tool is likely to be useful to communicate in other Wiles and contexts. And so you can see here a tool that was developed with the UQ node to help input data. So originally it was in a big spreadsheet. This allows community members to do this more independently. So it's a really valuable tool. And just looking forward, a research project funded through WSU is currently underway, in which Caroline Jones and I, together with Virpai, researcher Kuwan and Moran, in partnership with Multiword, Aboriginal Language and Cultural Cooperative, are working with a group of Gatang, Virpai, Wurunga, Waramai community members from Mid-Coast New South Wales to investigate exactly this, the use of this tool. Is it effective to help them develop a resource? The Lockhart River community, Cape York, is also working with this tool to try and develop a resource for their language. And finally, Caroline and I have begun a pilot project in partnership with Fresh Hope Care to explore the translation of this tool to the aged care context to support communication and relationships between residents, care staff and families. Thank you.
Time for one question.
Thank you, Mark. Over here. Hi.
I thought I recognised that voice. I didn't
Yeah, I have actually 10 questions, but okay, I'm going to choose one. The statistical outcomes were interesting. I was wondering if you also have a few qualitative ones in terms of engagement with the language, maybe confidence, maybe what got stuck. Did the people who used the app report back on that?
Thank you. Good question. So deliberately we didn't measure outcomes, which is what journals really wanted to do. Mainly because it wasn't really appropriate in this context. It's of course something you might want to do, but not in this context, particularly not at this time, given COVID, etc. But I know as a language teacher, we know from research that engagement with language, engagement is what is going to create a difference. So the data can tell us so much. It's inferential. We did we have a lot of data from talking to community members about what they're finding. So we do have the collected words that they said, I thought I'd learned this word. This is a word that that I really learned. One thing that was really important is that in that community, people use names for perhaps bush medicine or various plants that come from other languages. But the older people would know that, but younger people may not be aware of it. So this provides a way people are, is that the name for the Mungerai? And that was a really important kind of the important thing. I'd say that out of all of this kind of data, if you like, one of the most interesting ones was the notion of using it on country because it's kind of reference. Well, I want to know what that tree is. Here's the name of that tree, but it comes to you packaged in a set of phrases that could be useful for communication. So I think it's probably the most exciting.
Hi, I'm Wolfgang Barth. I'm the corpus manager at CoEDL. I think most people here should know me, or at least have heard of me. I collect data for corpora, to build like online corpora, which are accessible in the internet. It's a long way to a corpus. If you have data, I'm going to show you how it's done. So, that is a graph from Mount Everest. And I thought I'm going to take this as a metaphor for what it means to build a corpus, okay? So we would start at the bottom. It's a little bit off the map here. That would be the base camp, okay? That's where the endeavor starts. And if you think about corpora, that would be the equivalent of you get funded or you get a position where you have to do field work. And that is the starting point for the endeavor, okay? Then the second step would be the Khumbu ice fall, okay? That's the area here, and that is the tricky part. That is going into the field, collecting your data, making recordings, audio, video, engaging with the communities, and so on. Okay, so that's a very big part of your work. Then we get to camp number 1. That would be you get back from the field with your data in audio as recording, and you start transcribing this data. Okay? You would maybe use Elan to transcribe the data, you would use Clan or FlexText or whatever software you would use for transcribing. Then you get to camp number 2. You would use this data to write up a paper. Okay? So that's the goal of the research. You want to use it, write up a paper. And then you would send it out to a publisher with the hope that it gets published. Okay? Then camp number 3 would be you get to reviews. Okay? That's the tricky part, because then you have to rework your paper, maybe redo parts of your data, revisit everything you did in the steps before, and take it maybe to the next level so that the reviewers are happy with what you did. And then you and your data would get to camp number 4. Up here it's called point 5, camp number 4. And that is, your paper gets published. Hooray! You almost made it, but you're now in a death zone, and so your data at this moment is in real danger. Okay? So if your data hangs out here for too long, you're not going to get to the summit, which is the corpus. Okay? So every month or every year, your data sits on a hard drive somewhere on your shelf or on a cloud store or something like that. The chances are you forget about it. You move on to other endeavors, and the data never gets compiled into a corpus. From the camp number 4 to the summit, there's one bottleneck. Does anybody know what's the bottleneck on Mount Everest? That thing. It's called the Hillary Step, okay? Named after certain Hillary. And that's on Mount Everest, that's a 12-meter kind of vertical climb. And the problem is that only one climber at a time can get through there, okay? And so that's why you get like this traffic jam of climbers up onto Mount Everest. And if you translate this to building a corpus, that is the equivalent of having to clean the data and to standardize the data, having to map the data from one file to another, and so on. Okay, so for a lot of people, this is a really scary process. they think it takes a long time, and I'm here to tell you it doesn't. So why does it not do it? Why do we not have this bottleneck anymore in our process? So I developed a while back like a web tool where you can just take your files, your ELAN files, you drop them into the tool, and the tool gives you immediately, like it takes a millisecond, it gives you all the numbers you need about your files. Okay? So you get how many annotations are there in each annotation layer, how many words are there, how many letters are there, what is the content of each annotation layer. So this is something to like illustrate what you're doing, but it is also a tool which I use to get your data in shape. And how do I do that? You see like those checkboxes on the side. There I can like click what should be included in the corpus, what should not be included in the corpus. What should be the main tier of the corpus? If you think about like a dialogue, for example, you have two speakers. How should those two lines of annotation, how should they be incorporated into the corpus? Should it be corpus with two speakers, or should the words be lined up like on a string from speaker 1, speaker 2, speaker 1, speaker 2, maybe speaker 3, 4, 5, maybe there are several speakers. I build corpus where there's like 96 speakers, and they all are merged into one string of words. Okay? So this sounds like a tricky part, and if you would have to do this, you have to like think through it. But it's not when you have this kind of interface where you can just be like, this should be included, this should be included, and this should be included. That's an example of more files. Example of here picking like the tier M, MJK, and Flare as the main tier. So in this file, this would be the main tier I want to collect to build the corpus. And then at the end, when I do this all in files, and I'm done, I just click create configuration file. And what this does is it takes it to the technical level, so you don't have to worry about this. That's what I do as a corpus manager. This is kind of like the technical realization of all the decisions that have been made in order to build the corpus. Okay? And so each corpus in our corpus collection has one of those files behind which decides which tier of which file gets imported how into the corpus. Then this file is configuring the machine where the ELAN files come in on one side, and on the other side there's the corpus coming in. Okay? So this, from the beginning, you send me the files to, we have a first corpus that you can look at. It takes 2 hours. Okay? Then we import it into the corpus collection. So this is the online tool. And then, I don't know how many people are familiar with the online tool. It's called ANIS. It's developed by the University, Humboldt University in Berlin. And that's our interface where you can access the corpora. And that's what the data looks like based on the decisions we made in the configuration file. In this user interface, you can do queries, which are described, so you have like easy access to it. And the queries can get really complicated. I think this is from the Kuvaru, is Alan here? It was earlier, the Kuvaru corpus. So the queries you can do with this interface can be very sophisticated. So you can look for a word with a special translation in a special subset of files and so on. You can look for frequency of words. Here in this case, it's the frequency of word split up by the speakers. So the first word would be Philips as the word Nirim, 14,914 times or something like that. Okay? So it's state-of-the-art kind of corpus viewing tool that we use. And the searches can get really, really complicated. So this is like, look for speaker Francisca and the word goo translate as house in files which also in a file name contain Francisca. Okay, so it's a very, very sophisticated system. It takes a little bit to get used to it, but that's also like part of my job, teaching you how to do it. okay? And so what I'm doing in my job when I build a corpus is I interact with the people who provide the data. It goes back and forth. I told you it takes like 2 hours to build a corpus. We build a corpus, look at it together. People use the corpus. We go back, do it again. Build another corpus. They say, okay, this tier shouldn't be in the corpus. We take it out. You look at the corpus again, and so on. So it's a process which sometimes takes, I don't know, 5 iterations, sometimes 10, 20 times, going back and forth until the corpus is done. Okay? So this is not like you build a corpus and it's a massive step. You have to go and go, and it works at the end. That's like an ongoing process. Okay? So you look at it, the moment you start, if you decide right now you want to have a corpus, we can have a corpus in the evening, and then we start developing it to your lecture. Okay, that's pretty much it. Okay, and so there's I'm pretty much saying thank you, and there's a photo from Tenzing Norgay. I have a Sherpa who got 70 up on the mountain. And so you can think about me as
Questions?
Thank you. That's really interesting. I'm wondering how this workflow will live on after CoEDL, how it's been documented, how it's going to be shared. Does that make sense?
Yeah, that makes sense. We always start the process of archiving all the corpus, right? Because the corpus building process in most cases goes hand in hand with archiving and paradisec in most cases. But the corpus is a little bit, it's the same data, like the same raw data, but it's put together in a different way. And so the corpus is its own kind of item which can be archived the way it is in paradisec, and then people in the future can use it.
In ANIS, can you edit the transcripts? Is that also part of the corpus development? No, that's done.
No, so the ANIS is a viewer where you can only look at the data. So it's not a tool where you can interact in a creating or editing way.
Questions? All right, thank you very much.
That's it. All right. Hi, I'm Daan. This is Ben. We're wearing the same shirt. You haven't had it up too much to drink last night. That's just, the the Elpis outfit. We're sort of sad.
I'll bring one tomorrow.
Yes, please do. Yes, because I feel like we need to. Yeah, there needs to be a photo. The three of us. Anyway, enough about that. So I'm Daan, and I work with Google Research. I'm also on the advisory board. Previously, my colleague Craig Cornelius was also on the advisory board, and I'm sure he would have loved to be here today, but unfortunately he couldn't make it. So we just want to talk you through the work we have been doing on Elpis, and I'll just start where I got involved with the center, which was obviously at some point when the center had already been in existence for a little while. So basically the question that Janet approached us with at Google was, can technology help language work? And this is of course a question that had already been asked within, even the setup process for the center, and then when they reached out eventually, that's something that we discussed for a while. So Craig and I basically said, look, here's what exists today, right? Like we're aware that there are 7,000 languages. As far as we know, about 3,000 of them have some written tradition, and Craig has done a lot of work with Unicode to make them encodable and make them work properly in rendering and in fonts and all of that. So that was a lot of work that had already gone into that. I personally worked a lot on smartphone keyboards, and so we talked a bit about, okay, what are the different technologies that even exist out there that you might be able to use for language work, right? At the time, like maybe 6 years ago, speech recognition was available commercially in like about 100 languages, it's gone up a little bit since then. And to be honest, everybody in tech thought this was pretty good coverage. This was like, 100 languages, we feel good about that. We've even got like Uzbek and like, Armenian and all of that. But it became obvious through all these conversations with Janet and other folks in CoEDL that actually like it was falling far short of what was needed. And I mean, this seems obvious now, like the field now, even at ACL, the premier conference for natural language processing recently, it was all about bringing it to more languages. But at the time, 5-6 years ago, like people felt pretty good about 100 languages, right? Of course, Janet came to Google Mountain View and gave a talk and said, look, there's like hundreds of languages that we alone at CoEDL work on, and you should look at Paradisec. I think Nick T also came to visit us once and gave a presentation about Paradisec, and you could definitely see those bridges being built, right, between folks working on natural language processing, where historically the belief was, oh, we're doing pretty well in terms of coverage, and folks like Paradisec and CoEDL, where there were 1,000 languages. So as these conversations sort of matured, things got into slightly sharper focus with the transcription acceleration project. So Nick already mentioned yesterday, I think it takes quite a while to transcribe this data, as I'm sure you're all painfully aware. This isn't something, I just want to put this slide here because this isn't something that I had ever considered as a problem, from a language technology point of view, right? Like this is not something that comes up at Google when we look at, oh, what research should we do on language technology? This is not like a problem that we would normally encounter because it's, not something that you would normally see in languages like English or French or Chinese that we would normally work on. So this actually, this project was, I think it came out of this workshop that Nick T already mentioned yesterday as well. And Ben was the manager for TAP, so if you have any questions about that, you should actually ask Ben. The basic question was, can we help accelerate this process, right? Not replace humans doing this transcription work, but can we help accelerate this process using technology? So I said to Janet when she was visiting 6 years ago in California, I said, of course, like there's all these like toolkits that you can use. They're already open source. Just we'll walk you through it. We'll hook you up with TensorFlow, which was relatively new, or Caldi, or some other toolkits. This is a doable thing, right? And in fact, it was quite doable because Oliver Adams, who was a PhD student here in Australia at the time, in 2017 built this system called Persephone, which you might have heard of, which made it work quite well, speech recognition, so taking audio and turning it into text, with relatively small amounts of data. And he already focused on like improving the workflow, accelerating things, and he also thought, look, if we can make this work well enough, we can make a correction workflow where you can have a snowball effect later on where things will improve as you sort of feed more data into it after correcting it. So this was all looking quite promising in 2017, so 5 years ago. The main problem was that this was still relatively hard to do for any non-expert, right? So if you didn't already have a PhD in speech technology, this was relatively hard to do. So Janet invited Craig and me to come visit Australia, and we did this, I came to visit Brisbane. We did this workshop. You've seen this photo probably all the time. This is us stumped because this amazing toolkit that I had mentioned that like would pretty much solve this problem wouldn't even install on the university computers. I don't know how many security alerts we triggered that week, but I'm pretty sure the UQ IT people must have gone, I don't know what's happening in that building, but something shady is going on. But like there were 20 people from like the computer science department, some Google software engineers, and we still couldn't make it work properly. I don't know if this was ever revealed to you, Nick, but when you did get that demo, at the end of that week, we had just gotten it to work like about half an hour before you were about to walk in, despite like, 3 days of like banging our heads against this. So actually, like we did get it to work, right? It got some results. It worked reasonably fine. The downside, however, was that we had to basically argue with this for like 4 days before we could make it work. And if that looks intimidating to you, don't worry, it looks intimidating to me as well. But I just happen to know what it says, right?
There's some nice little code messages in there, including the words, this is probably a bad idea.
Yeah, those things are always very good. So basically at that point, we had like a proof of concept, but the question was, can we make this easier to use so that people can actually use it? And I'll hand over to Ben. who has been driving that.
Thanks, Dan. Yeah, so it's quite a daunting, it was quite a daunting experience to use this interface to the tool. We got some results. Some of the braver people in CoEDL went through it, and the people in the room who've been with us from the start would probably remember some of that pain. So we're feeling that we were getting some results, but the experience was pretty dreadful. We might have felt kind of cool like hackers in a TV show, but it was not a nice experience. And so over the next, we had an iteration, the 2018 summer school, I think it was, that we ran a summer research project to develop a graphical user interface to Elpis, which was to move away from that command line thing to have buttons instead. So Pete just talked about the value of buttons, the importance of having buttons in interfaces. In physical interfaces, buttons are really important, and for a lot of computer interactions, having buttons is helpful, nicer than typing instructions into a command line. So we developed this Elpis graphical interface that you could use as a sort of a wizarding thing where you could drag and drop your files into a web browser, click some buttons, and at the end of it have a speech recognition system. That was pretty cool. And that happened within about 8 weeks, that first proof of concept. I remember demoing it at the CoEDL Fest after the summer school, and we had a couple of really late nights. It looked like it worked at that CoEDL Fest, but to be honest, it was a what do they call it? A wizard of Oz. It pretended to work during the fest, and it was just at the end of the week that we actually got it wired up. And so since the GUI has been available, it's been used for language research, it's been used for medical app translation interfaces, and I'll talk about that in a moment. And since that first GUI, we've gone through some iterations of improving code, because a lot of people have been involved in it, as well as the linguists. We've had software engineers who've had their first experiences of working in language tech through this, so of course improving the quality of the code has been important. And we've swapped out the speech recognition engines. So when Dan first came and showed us that Calvi thing, there have also been some very significant improvements in speech recognition technology over those few years. And so just in the last year or so, we've included the Hugging Face Transformers Wave to Vec 2 system. And I'll talk more about that in a moment. And so over that time, we've improved the interface, and we've made the access to the underlying technology easier. The technology's improved as well. And so the first version of this slide, which some of you may have seen already, the results here, Zara Smith, who's in the audience somewhere, running around with a microphone probably. The first versions were using Calvi, and the error rates were maybe above 50%, so maybe 60% of the things were wrong. There was still some recognizable output. With the latest version, the Wave to Vec 2 system, the results are just staggering with very small amounts of data. But it's not always like this. I've handpicked probably the best out of it, but that's what you do, right?
I was noticing a fairness which chose like one language, so it performs okay even though my data goes between 2 languages, so we should say that that's a bilingual model.
Yeah, so this is part of Zara's research, and I hope she'll be talking about this more tomorrow, is that in the language research, so you can use Elpis to get output if you just want to get from camp 2 to camp 3 more quickly, and use Elpis to get a rough transcript, and then you can correct it. But you can also use Elpis to help with questions about language. So how similar are languages? Can you get a better automatic transcription by combining 2 languages than you might get from just working with one? So there's applications in terms of language research as well as output or corpus kind of benefits. Yeah, so that's some results. Some results with working with Daan, and again, the early Calvi work was pretty rough, and the earlier version of this slide also showed 2 outputs, and one was highly accurate because it was trained on a very small data set, but then it was validated, or the output that we showed was from pretty much exactly the same words in exactly the same context. So when you use speech recognition, sometimes you're likely to get the best results if you're using the system that's trained on some data and you're trying to get some results for maybe the same speaker talking about the same stuff and the same quality of audio. as soon as you diverge from that, maybe you want to transcribe someone else who wasn't included in the training data, then it might suffer in the data. Here we can see that in the top set of results, again, the quality is quite high. The second set, it's still pretty good, and this goes back to Oliver's point that sometimes the output is not necessarily, you wouldn't just spit it out and use it in some sort of legal translation context or something, but it might be a good basis to correct. There's been some good publications about that changing workflow from sitting and putting the headphones on and thinking about transcribing with a blank elantia. It's a bit daunting, it's like trying to write poetry with a blank piece of paper compared to editing hypothesis that the machine gives you. There's a lot of discussion about potential bias and things in that, but if there's an awareness of that, then it can certainly help in workflows. So the second set of results here, maybe a little bit less immediate benefit, but there's certainly enough words in there, or even the character level, there's some improvements that we can make in that. So other applications around that, outside the language research context, we've been working with the Wonkapuchu translator app that Purple House and Highway Learning have been developing in Alice Springs. And so this is a translator app that people use in a medical context to translate back and forth speech in, the doctors speak into it in English, and we'll get some speech out translated in Lurch language, or the other way around. So this, the application itself was developed all by Purple House and Highway Learning. I read about it in the ABC News one night, and I thought, they've done it, our job's finished, I'll get in touch with them and I'll find out what they did, and maybe we can just get a copy of it and that'll sort it out. But it turns out that actually the ABC hadn't told the whole story, and they were missing this little part of the puzzle, which was the Lurch speech recognition part. And we're back to the drawing board. So we've been working with them over the last couple of years, and it's a really lovely collaboration. So Elpis is running on a cloud server that they've set up, and you can speak into the app, and it gets sent to the cloud server, and you get the transcription back, and then it gets translated inside the app. So that's pretty cool. As Nick mentioned, we're about to start doing deep dive into paradisic with Elpis to potentially, well, maybe one of the endpoints of that might be to have a script that runs when you deposit into paradisic that does an automatic transcription of everything that you haven't transcribed yourself. Label it very clearly as this is generated by a machine, use with caution, but there's potential there to enrich corpus that you deposit into an archive, particularly if we think of the outputs that maybe not necessarily 100% accurate, but even if they're 60% or 70% accuracy, that might be enough to facilitate a text-based search. So currently, language technology is not quite good enough to do searching based on speech alone. We're still relying on text as a discovery interface. So we can generate a hypothesis transcription that might really facilitate some better searching or some better access into the data. So future directions, where to from here? CoEDL's coming to an end, but Elpis sort of lives on, and we're about to make a big jump. So Elpis at the moment runs on your computer. Some of you have been through the workshops with us where you download Docker. It's a virtual machine that runs on a machine that runs on your own computer, and that means that we just develop one version of Elpis, irrespective of whether you're running, whether you're using a Mac or a Windows machine or a Linux machine. So we developed one piece of software, the Docker thing virtualizes that across the different host computers. We're starting work on well, we're almost finished. I was hoping we'd get it done for this, so we do a big reveal, but it's not quite ready yet. It's a cloud-based version that you could just go to, sign in with your Google, your Gmail account, or your whatever, and you access Elpis in the cloud, so you don't have to install anything on your computer. So it seems like the last bottleneck, speaking of bottlenecks, we talked about the transcription bottleneck before of it taking, 40 minutes or 100 minutes to transcribe 1 minute. The software, the technology seems to be helping that part of the bottleneck. That seems like the last major bottleneck in terms of the Elpis stuff is that the installation process, and not the installation of Elpis, but the installation of Docker, the thing that you need to run Elpis. So that we're trying to remove that dependency by having a cloud version of it. So stay tuned for information about that. And then, so that suits some ways of working. We'll probably maintain the local version because some people don't have the ethics or permissions to send their files to the cloud. So we'll keep the current version of Elpis there for those use cases. Integration of Google Colab online notebook. So an online notebook, some of you might be familiar with these things. The programming language Python, you can run it in a web browser. You can do scripts, you can run scripts in web browsers. Notebooks are nice because they can mix code. So this is a notebook, this thing here. These grey boxes are code cells, so for those of you who use Python, this might be recognisable with some Python code here. And the nice thing about this is that you can mix rich, decorative documentation in with the program that you're using. So people, and you're out for these things, we'll start to see more and more of this type of analysis used in research notebooks, code notebooks maybe. We're looking at integrating this way of working with Elpis so that maybe you use Elpis to train a speech recognition model and then send it to an archive or a repository and then potentially use these notebooks to do further analysis based off that already trained model. So thinking about mixing up these different ways of working. Sometimes the buttons, the graphical interfaces are the best ways of working with this kind of tech, and other times it might be beneficial to have a little bit more access into the code. The nice thing about notebooks is that you can make the code a bit friendlier. Like compare that to the screen of blue and white text that we saw earlier. This is a little bit friendlier. So another benefit of the notebooks is that it makes it easier to archive the results that you get from using things like Elpis. You can generate a DOI, for those of you who know archiving, these persistent identifiers. You can kind of make a snapshot of that code and your data and then archive that so that other people can easily recreate your experiments. That's coming up. So that is, we're hoping to move a lot of that development over to the Language Data Commons in Australia and ATAP project, thanks to Michael Moore, after CoEDL wraps up, so that we'll continue upwards through that, and along with some of our international collaborations. And Tanae and Oliver are doing some more work around the kind of experimental aspects of Elpis and speech recognition. How do we improve the results that we get? So already we're getting really good results out of this work to Vec 2 system, but we think we can do better. So Nate's about to do some work on things like the way to Vec 2 system has the version we have 50,000 hours of data. Starts with that. So imagine how long it would take to put or to document 50,000 hours of material in the languages that you work with. So it starts with that. It's multilingual. Well, when I say multilingual, there's about 12 languages, or maybe more, maybe 50, up to 50 languages. Still mostly English, but there are other languages in there. And the process is that you start with that and you fine-tune it with the data that you have. So if you have 2 hours of data in your language, or 12 or 8, then you make a version based off that big 50,000 hour model. You fine-tune it, you pre-train it. So now he's going to look into some ways of, if you've got 3 hours of transcribed material, but you might have another 20 hours of recorded material that's not transcribed, can you use that untranscribed material to also benefit that process? Other things like subword modelling. At the moment, the transcription can either be at phoneme level or at word level. What happens if you've got a, say for example, a polysynthetic language, how do you deal with that? Or even a non-polysynthetic language. If you break down the words into subword parts, so like morpheme chunks, rather than full words, can you get better results out of the system? So these are some things that Nate's going to try. If it works, we'll build it into Elpis. If it doesn't work, we'll say, no, this is an experiment. And some other things there. So, thanks. Yeah, look, while we're waiting for the microphone, I'll just say we couldn't have done it like Dan and I, although we have great fashion sense, we wouldn't have been able to do this on our own. So this is really thanks to these agreements.
Can I ask you how you deal with the emergence paradox? That is, when we're interested in how structures emerge, they usually emerge from hastily enunciated, rapidly formulated things like no, or whatever. And we want to know several steps along the way, but I imagine that your goal is to sort of gate them into more definite transcriptions, like I'm gonna, or whatever. So, but that fact that there's all of this pale spectrum of different realizations is something we're really interested in to understand the emergence of grammar. And what pathways do you see in terms of keeping open the fact that there's quite a lot of blurring around certain typically high frequent words, which are often also the hardest ones to transcribe?
Yeah, that's a great question. So it's not exactly related to the emergence paradox, I think, but it sort of brings to mind the way that these systems already work today, right? I think we had some audio from Sydney Speaks this morning. If you look at the transcriptions there, those were not the transcriptions that you would normally see in, let's say, subtitles of movies, right? Because we would like remove hesitations or fillers. So increasingly there's work around how can we not just provide one transcription, but having tiers of transcriptions, right? Where you say, oh, this is what we would put in the subtitles. Maybe we would get rid of the hesitations or the fillers, or but maybe we can make another output tier, so we don't just get one sort of string of text that comes out, one sequence of words, but we get two sequences where one of them is this is what we would write in formal English. Here's where we keep the fillers. Here's where we keep the hesitation. So I guess you could imagine, putting that as another tier on top of it. And some people are also doing phonemes as one tier, then a more sort of literal written transcription as the next tier, and then finally the sort of cleaned up tier. So I guess you would sort of look in roughly that direction, but yeah, I think Elpis would support that. I think it would mostly be a question of what is the sort of underlying linguistic phenomenon that we want to assign to each of these tiers, right? That I think would be the question.
And I'd also add to that, it would only learn about those things if they've been transcribed, if it could train with that level of detail as well. So we had a fascinating question a little while back, contact from some people in, I think they were from Leipzig, uni, who wanted to train a system to learn about all of the ums and ahs in a recording. Now they're usually the things that, nobody really transcribes all of the ums and ahs. These are things that people leave out, and so it would be very difficult to, you couldn't just, you'd have to create a corpus, especially of ums and ahs, so that you could learn that sort of thing.
One thing on naming. Yeah,
so it depends on the training data as much as, the technology can do it, so the Elpis output at the moment might be on word level and then utterance level, because some people want to know just the word segmentation. For other people, the utterance segmentation is important, and so then it would be, stick another tier on it.
Okay, so can I ask you to hold the rest of your questions until the break?
New shirts, right?
So a few of the presenters escaped without being acknowledged. So Pete and Wolfgang, please come.